Good morning, students. So in the last video lecture we discussed about the fundamental rules of matrices, then some properties of matrices, especially rank of a matrix, adjoint of a matrix, then cofactors of matrices. Those properties can be used to find out the inverse of the matrix, which are very important in matrices. The continuation of those properties which we are going to deal with today, that will be used also in three topics. So today we are going to discuss three topics. One is on a transformation of matrices, then another one is on characteristic equation, then the last one will be on eigenvalues and eigenvectors of the matrices. And the properties which we learnt in the last class, that we are going to use today: cofactors, adjoint of matrix, and all those things, inverse of a matrix, and all those things that we are going to use in the transformation of matrices, then characteristic equation, and then the eigenvalues and eigenvectors of the matrices. So that's the idea of today's lecture. The transformation of matrices mean we are going to transform from one system to another system. So we are going to have the transformation from one system to another system, or one system to another system to another system. So it goes on. The first one is a linear transformation, and the second one is combination of transformation. We are going to combine. Suppose if there are three transitions, we are going to combine all the three. So first one will be transformed to another one, another will be transformed to another one. So we are going to do subsequently. So those transformations are called combined transformation. And the first one is a linear transformation. From one system to another system is nothing but a linear transformation. Linear transformation means we are going to apply linear operators. The transformation, it can be either stretching. You can stretch the matrix, you can stretch the direction, you can stretch the magnitude. One is, or otherwise you can shear it, or otherwise you can have a rotation. And all those things, they come under transformation. Either you can stretch, or you can shear, or you can have a rotation. So all those things will come under transformations. But whenever we talk about eigenvalue problem, only stretching alone is possible. There will be no rotation, there will be no shearing at all. Because in eigenvalue problems, in eigenvectors, the operators which will act on any matrices will give us the eigenvalue with the matrices. These operators will be always linear. So I repeat, the operators are matrices which when we transform from one system to another system to find out the eigenvalue, it's nothing but eigenvalue is nothing but a proper value. And there will be only stretching alone will take place. Either it can be positive direction or negative direction. Even eigenvalue can be a positive value or negative value. If it is a positive value, then the direction will be enlarged. The magnitude will be enlarged. That's called a stretching. Whereas if it is a negative value, it will be in the opposite direction. So this is the idea. And of course we know about eigenvalue. Eigenvalue means, eigen means the proper value. It's nothing but the roots of the characteristic equation, which we are going to study. So characteristic equation are the solution that we are going to obtain for some equations. For simultaneous equations will be there, we are going to get the solutions. So those solutions are nothing but from characteristic equation. And transformation matrices is, as I said, we are going to have the change of coordinates from one system to another system. So as I said earlier that the operations are linear. Okay. So transformation of matrices, under which we are going to deal with the linear transformation. Let a point P x comma y in coordinate system xy. So that will be transformed to the point another x1 comma y1. Okay, in the coordinate system x1 y1. And what are the relation? x1 will be a11x plus a11y. And similarly, here there is a mistake, a11x plus a12y. One y1 will be a21x plus a22y. See a1, a12. So this is, there is a mistake here, a12. And this equation, simultaneous equation, can be written in terms of matrices. See here, x1 and y1 on left hand side, you can have a column matrix, and a11, a12. So a12, similarly a21, a22 can be written in terms of a matrix, and the remaining in x and y. So this is in one coordinate, this is in another coordinate. So we are going to transform from one coordinate system into another coordinate system. So the matrix operation will operate on this, will give you new result. That new result will be in the another coordinate. Is it okay? So xy is in one coordinate, xy is in one coordinate, x1, y1 is another coordinate. So we can transform. This transformation is nothing but a linear transformation. So x is transformed into y is called a linear transformation. Generally we can say that y equals ax. Generally we can say. So A matrix operates on x, will have another system, that is nothing but your y. For n dimension, so that is for 2 dimension. So this is for 2 dimension. Only two things are left. So x and y are there, x coordinate and y coordinates are there. So 2 dimension. For n dimension, the matrix can be written as n dimension matrix like this. So and also corresponding x1, x2, x3 dot 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 xn, y1 dot 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 yn. What are the properties? Very important property is det A. So suppose if you take a matrix, determinant A equals 0. What we call this as singular matrix. We know already. Singular matrix. Suppose if det is not equal to 0, we call this as non-singular matrix. Sometimes we call this as a regular matrix. To find out the inverse of a matrix, we need to have non-singular matrix. Correct? We need to have a non-singular matrix. If we want to know the answer for the inversion of many matrix, we have to go only with a regular matrix, non-singular matrix. So this is what is given. So y equals ax is a regular matrix because det A exists, and this can be written as x equals A inverse of y is called the inverse transformation. So inverse transformation. As I said earlier, we need not go for 1 to 1. We can have 1, 2, 3, 4, 5 goes on. Suppose if we have 3 systems, we are going to change from one coordinate system into another coordinate system. Then y equals ax. Then another coordinate is z equal to by. See here, y equals ax, and then another coordinate is z equal to by. So we have now 1, 2, 3. So the system will transform from 1 to 2, then 2 to 3. That's called a composite linear transformation, combination. And 2 or more transformations, one after the other. One after the other. And what is the answer? See, you have z equals by, correct? Instead of y, you substitute ax here. Ax here. So you will get bax. And z can be written as bax. So B is a matrix, A is a matrix, X is a coordinate, and Z is a coordinate. So we have changed from X coordinate to Y, Y coordinate to Z. So Z to X, one after the other. This is called a composite transformation, composite linear transformation. Okay, so we will see some examples for linear transformation. So it's given as y1 equals x1 plus x2 plus 2x3, and y2 is given as 2x1 plus x3. x2 is not there, you have to consider as 0. Then y3 equals minus x1 plus x2 plus x3. So convert this one into matrix form. We can write exactly as y1, y2, y3. See, y1, y2, y3. And what are the matrix? 1, 1, 2. See here, 1, 1, 2. As I said, 2, 0, 1, 2, 0, 1. Minus 1, 1, 3. And what are the x1, x2, x3? So this is exactly of this form. Y equals ax. What is asked? Show that the transformation is non-singular matrix. So we are going to find out the det A. We will find out. Find the inverse transformation. So we are going to find the inverse transformation. So first point is det A. Det A, we know already how to find out det A easily. In the last video lecture, we clearly explained. To find out the det A, the answer is minus 4. So inverse exists. Okay, it's a non-singular matrix. So inverse, we can find out the inverse. And of course, use this formula, y equals ax. We will have x equals a inverse y. Okay, X equals A inverse Y. A inverse, in the last video lecture we found out at GA divided by det A. What is at GA? Cofactor of matrices. We will have to take the transpose. Okay, the transpose of the cofactor of the matrices. This is what we learned in the last video lecture. So at GA is given as this, and we will have to find out the cofactor of each element. Okay, so this is the given matrix. We will have to find out the cofactor with the sign, very important, with the sign. So first cofactor will be your 0 1 1 3. See, 0 1 1 3, which is equal to minus 1. Second one with a minus sign. See, minus sign. C21 is given as C12 is here. Okay, C12 is here. 21 minus 1 3. C21 minus 1 3. C21 is here. So C21 will be 1 2 1 3. Your C2 you will have to do like this, 1 2 1 3. See, 1 2 1 3. So like that we can find out all the cofactors of the matrix, of the given matrix, 3 by 3 matrix. So we have found out now cofactors, and transpose of the cofactor will give you this. We are going to change the rows into columns, columns into rows. So it's A inverse equal to at GA divided by det A, it's given as this. Very simple one. Okay, so A inverse is, I have brought 1 minus 1 by 4 inside the matrix, so it's given as A inverse is given. Okay, any doubt? A inverse is given as this, and X equals A inverse Y. So you have x1 x2 x3 in terms of the matrix form, linear transformation form, and this is your A inverse, and the y will be y1 y2 y3. Now x1 equals, you multiply these matrix multiplication, so that will give you 1 by 4 y1 plus 1 by 4 y2 minus 1 by 4 y3. So that will be your x1. Similarly you can go for x2, similarly you can go for x3. Very easiest one. Any doubt? Simple one. Okay, now we'll go for some other problem on composite transformation. So this time we are going to have 3 coordinates. It's a composite transformation. It is combination. So 1 2 3, as I said, one after the other. So we will see x1 equals 3y1 plus 2y2. y1 is z. See, y1 equals z1 plus 2z2, and x2 is given as minus y1 plus 4y2, and y2 equals 3z1. See, we have now x, y, z, 3 coordinates exist. That's why composite transformation will come. So in a matrix form, and find the composite transformation which expresses x1 x2 in terms of z1 s2. So x1 usually will be written in terms of y1, but here we are going to find out x1 x2 in terms of z1 and z2 through y1 y2. Also write x1 plus x2 in terms of z1 and z2. We are going to find out. Now, so given matrix, this matrix can be written as x1 x2 equals 3 2, correct? 3 2. Similarly x2 is given as minus 1 4, y1 y2. Similarly y1 in terms of z1. So y1 y2, you have to write 1 2, then y2 will be 3 0. So z1 z2. Okay, so x equals ay, y equals bz. For any composite linear transformation, the rule is like this: x equals ay and y equals bz, and the composite transformation x is given as abz. So this is your a and this is your b. Very simple one. So a, b and z. So you have to multiply, matrix multiplication, you will get this. So after simplifying, you will get this. Okay, now x1 in terms of z1, we can write x1 in terms of z1. So x1 is given as 9z1 plus 6z2. Similarly x2 is given as 11z1 minus 2z2. Now what is asked in the problem? x1 plus x2 is asked. Here we have found out x1 in terms of z1. And what is asked? x1 plus x2 we have to write in terms of z1 and z2. So x1 is given as this, x2 we have obtained from previous step. x1 plus x2, add these two will give you this. See, now x1 plus x2 is given as in terms of 20z1 plus 4z2. Any doubt? So we have solved some problems for on linear transformation and composite linear transformation. Okay. Now a comparison of two matrices for a linear transformation. So we will solve one more problem on linear transformation. The matrix A is given. Okay, matrix A is given. This is a condition for the linear operation. See, the linear operator operates on real space, will give you real space in some other coordinate system. So it is given. So find the matrix relative to the basis. The bases are given like this. Okay, the bases are given. These bases can be written in terms of matrix like this. First point, you have to write the basis in terms of matrices. See here, 1 1 0, 1 minus 0, then 0 0 1. You find the P inverse. You just take this as P. Okay, you consider this as P. You find the P inverse. That will be your assignment. You know already how to find out P. P inverse. What is P inverse? Adj P divided by det P. Det P. Okay, this must be a non-singular matrix. Det P should not be equal to 0. So you can find out the inverse of a matrix. That will be your assignment. So now the relative matrix will be P inverse AP. So this is that you have found out, P inverse. This is A matrix which is given in the problem. So this is P matrix. So P inverse A P, you just have the matrix multiplication, you will get the answer. This is the required answer. Find the matrix T relative to the basis. The formula is P inverse AP. Okay, any? Okay. Use matrix inverses to solve the system below. So now equations are given. So simultaneous equations are given. X plus y plus 2z equals 1. 2x plus y equals 2. So z is 0 here. X plus 2y plus 2z, which is equal to 3. So convert this one into matrix form. So A can be written as 1 1 2, 2 1 0, 1 2 2. And your x will be x, y, z. And what would be 1, 2, 3? As usual, you will have to use the formula Ax equals b. So your A is here, x is here, b is here. And your x will be A inverse b. So you have to find out A inverse. That will be your assignment again. We have already done earlier. And you have to find out the A inverse. So x equals A inverse b. You just have multiplication, matrix multiplication. You will get the answer. Matrix multiplication will give you this answer. So your x will be 0 to minus 1 by 2, which is nothing but 0 to minus 1 by 2. So that will be the solution of the problem. Okay. So x value is 0, y value is 2, z value is minus 1 by 2. Of course, you can solve directly. You can solve this problem. How you are going to solve this problem? See, you multiply by 2 here and you just subtract. The x will go off and you will have only in terms of y and z. And again you multiply by 2. You just subtract. Again x will go off. For these two equations you will have y and z. Already you have one y and z here. Y and z. Multiply with the same number, that will give you only z alone. Z value. Then you substitute in y value. Then substitute in x value. You will get x, y, z. So this is the ordinary method. And this is matrix method, which is very simplified one. So we can get the values of x, y, z easily by using inverse of a matrix. So this is the idea. Now orthogonal matrix. So linear transformation y equals ax. What is the formula that we learnt in the last class? Can you remember? For orthogonal matrix. A dagger, this is equal to identity matrix. So this is what we learned. Okay. For any orthogonal matrix, A matrix will be there. You will have to transpose a matrix. You will have to multiply these two. Will give you identity matrix. This is what we learned in the last video lecture. Now, a linear transformation y ax is called orthogonal transformation if A is an orthogonal matrix. So we will see. So xi is given. This is for xi. Xi equals x cos alpha minus y sin alpha, and eta is given as x sin alpha plus y cos alpha. Prove that the transformation is orthogonal and inverse transformation. Okay, we are going to find out the orthogonal transformation and also inverse transformation. So now writing this equation in terms of matrices, we will get exactly like this. So xi eta, which is equal to matrix form. In a matrix form, you can write this as cos alpha minus sin alpha, y cos alpha, and x and y. So this is of the form y equals ax. Now we know that A inverse equals A to the power t. Transpose of this matrix is nothing but A inverse. Using this, A transpose A equals your identity matrix. You multiply on both sides by A inverse. A inverse will get cancelled, correct? I multiplied by A inverse will be A inverse. So A transpose will be A inverse. Okay. So A inverse equal to A transpose. What is A inverse? HGA divided by, so you have to find out now HGA for this. Okay, the idea is you are going to find out A inverse for the matrix A. Okay, then for the matrix you are going to find out A transpose. These two matrices should be the same and it will be the same. Only then they are orthogonal to each other. I repeat, matrix is given. See, A matrix is given. You find A inverse first. Okay, get the value, get the matrix. Then after that you find A transpose of the matrix of A. These two matrices should be the same. If it is same, we can say that A is orthogonal to each orthogonal matrix. So A is given as this. First we have to find out det A, which should not be equal to 0. So det A is given as cos squared alpha plus sin squared alpha. We know that is equal to 1. You find out now HGA divided by A. Okay, to find out A inverse. So what is cos alpha for HGA? That will be, you have to find out this one. That is cos alpha. See, cos alpha. Is it okay? Then for sin alpha, 1 minus is there. So minus. That minus will go off. You have sin alpha. But this one will be minus sin alpha. Okay, 1 minus will be there. Then you have to take the transpose also. See, A inverse. See, you have to find out HGA. HGA is transpose of a cofactor. You have to find out first the cofactor. Then you have to transpose. You will get this. So your A inverse will be this one. You find out HGA divided by A. Now, what is A transpose? What is A transpose? This is ordinary, our ordinary one. See here, this is ordinary one. What is A transpose? This is nothing but cos alpha. This sin alpha will come here. This minus alpha come here, cos alpha. This is from here we have obtained. This is from here we have obtained. Okay, this one from using this one using this. So now both the terms are equal. See, both are equal. So we can say that A inverse equals A transpose. So A must be orthogonal matrix. Now then another question is asked, inverse transformation. So x equals A inverse y, you have to find out. So this is your A inverse y. Then that will be your matrix multiplication will give you x equals xi cos alpha plus eta sin alpha. Then another term will be y equals minus xi sin alpha plus eta cos alpha. Okay, so this is the second part, and this will be your first part. Orthogonal matrix and inverse transformation. So this one you have to find out cofactor and transpose and divide by det A. Det A is 1. You have to find out. Okay. So now trace of a matrix. So trace of a matrix we have already dealt earlier. As I said earlier, just add the main diagonal elements. Sum of the diagonal elements. Just add all the diagonal elements. Sum of the diagonal elements. That will be the trace of a matrix. So what is the trace of a matrix here? Then you are going to add all the diagonal elements. 1 minus 1 will get cancelled. You have 1. So answer is 1. So trace of a matrix is 1. Okay. 1 plus 1 plus 0 minus 1. So that will be answer as 1. Trace of a matrix. Any doubt? Now we will go for the next session. characteristic equation. So example 1. So we are going to find out the characteristic equation. So what is a use of finding out the characteristic equation? We can find the solution. So that's the idea. We can find the solution easily using matrices. So now we are going to find the characteristic equation. Okay. Now A minus lambda I is the characteristic equation. So you have to learn by heart this formula. A minus lambda I is the characteristic equation. Okay. So A is given as this minus lambda multiplied by your identity matrix. So lambda 1 0 0 0 1 0 0 0 1. Is it okay? Now see, I am going to multiply this. This is a scalar. Minus lambda is a scalar. Multiply this and I am going to add these two. So that will give me 1 minus lambda. Correct? So this is your lambda. This is your lambda. This is your lambda. Correct? It will become lambda after multiplication with the scalar lambda. Then 1 minus lambda. Here also minus lambda. Here also minus lambda. How many roots will be there? This is 3 by 3 matrix. This is 3 by 3 matrix. How many roots will be there? Surely there will be 3 roots. If it is 3 by 3 matrix, 3 roots. 4 by 4 matrix, 4 roots. As I said earlier, mainly we are going to deal only with the square matrix. Can you remember? Square matrix is more than enough for learning quantum mechanics. Okay. So for 2 by 2 matrix, there will be 2 roots, 2 solutions. 3 by 3, we will have 3 solutions. 3 roots will be there. So you have 1 minus lambda, minus lambda, minus lambda like this. Now you are going to take the determinant. You are going to take the determinant. Correct? Take the determinant. So 1 minus lambda multiplied by 1 minus lambda multiplied by lambda square minus 1. Other things will become 0. See? So you have 1 minus lambda, lambda squared minus 1 equals 0. So either 1 minus lambda equal to 0 or lambda squared minus 1 equal to 0. So we can have 3 roots, correct? So your lambda will be 1. 1 minus lambda equal to 0 means lambda will be 1. Lambda squared minus 1 equal to 0 will give you lambda squared equals 1. So lambda will be plus or minus. That's all. So we have 3 roots, 3 solutions. Now come here. You multiply these two. So that will give you lambda squared minus 1 minus lambda cube plus lambda. You write in terms of orders minus lambda cube plus lambda squared plus lambda minus 1. Left hand side you have det A minus lambda I. What is this one? This is the characteristic equation of this matrix. Very simple. Very, very important also. Okay. So we have found out now the characteristic equation of the matrix A. Okay. Now we'll solve some other problem. Find the characteristic equation of this matrix. This one is 4 by 4 matrix. See here, correct? 4 by 4 matrix. How many roots will be there then? 4 roots will be there. Your characteristic equation will start from lambda to the power 4. So it should start from lambda to the power 4. So solution. So from A minus lambda I is the characteristic equation. This is the form. Okay, so det A minus lambda I equals det. So this is your det. It is not matrix, this is det. Okay, there's a mistake here. So already it is given as det, so no problem. So it's the same. So det, we are going to find out det. As usual, you will have to do like this. So 5 minus lambda, you will get 5 minus lambda, you will get 3 minus lambda, 5 minus lambda, 1 minus lambda. I have taken this alone. See, this is, what is this one? Can you remember? Yesterday discussed. Echelon. Okay, we need not go for other operations. We can go for this operation alone. Or we can go for either this operation alone. Other things will become 0. You need not take, for taking determinant, you don't take this one now. You can go with like this or you can go with like this. You will get the same answer. So you will get 5 minus lambda, 3 minus lambda, 5 minus lambda, 1 minus lambda. The characteristic equations are, is given as 5 minus lambda squared, lambda squared, 3 minus lambda, 1 minus lambda. So you have lambda minus 5 whole squared. I can write on the other way around, lambda minus 3, lambda minus 1. Taking one minus sign out, minus minus will become plus. This already minus square, so that will become plus itself. So you will get this equation. Then this equation is known as characteristic equation of the given matrix. Very simple. Now find the characteristic equation of a matrix 1, 2, 0, 2. So we are going to find out the characteristic equation. We are going to have another method. You can learn so many methods to solve. We are going to learn now another way of getting characteristic equation of this matrix using this formula. This formula goes like this: lambda squared minus s1 lambda plus s2 equal to 0 for all the problems. Okay, for all 2 by 2 matrix. This is the formula. Okay, your s1 is nothing but sum of main diagonal elements. S1 is nothing but sum of main diagonal, the trace of the matrix. And your S2 is nothing but det A. Okay, you find out for a matrix, you find out det A. You find out the trace of a matrix. You substitute here, you will get the characteristic equation. This is another method. Okay, for 3 by 3 matrix. So this is for 2 by 2 matrix. This formula for 3 by 3 matrices. So lambda cube minus s1 lambda squared plus s2 lambda minus s3 equals 0. And here, as usual, s1 is nothing but sum of main diagonal elements, and s2 is nothing but sum of minor of main diagonal elements, sum of cofactors. Okay, minor means cofactor. So sum of minor of main diagonal elements, sum of cofactor of main diagonal elements. That's a trick. Okay, we will discuss. So this is given as main diagonal elements. Of course, S3 is nothing but det A. So this is for 3 by 3 matrix, and this is for 2 by 2 matrices. We will solve some problem using this formula. It's very easier. So matrix is given as 1, 2, 0, 2. We are going to use this. So sum of the main diagonal elements. What is the sum of the main diagonal elements? So which is equal to 3. What is det A? Det A is given as 2. See, 1 multiplied 2. This will become 0. So 2. You substitute here. You just substitute here. So you will get lambda square. So minus 3 lambda plus 2 equal to. So this is your characteristic equation. Simple. So this is another method. So this is your characteristic equation. Now we will go for 3 by 3 matrix. Let us see how it goes. So you have the formula exactly like this. Okay. Now first you calculate the trace of a matrix. So that will give you 8 plus 7 plus 3, which is equal to 18. So S1 is over now. What is S2? Sum of the minor of the main diagonal, cofactor or minor? Minor of the main diagonal elements. Don't forget, this is very important formula. Main diagonal elements. Okay. Now this is one main diagonal element. This is another main diagonal element. This is another main diagonal elements. Okay, not in row terms or column wise. You have to take only this one. Don't forget, it's very, very important. Okay, you may miss this one. See here, first one, we will calculate for first one, 8. So that will be 7 minus 4 minus 4, 3. See here. What about another one? This is your 7. Next main diagonal is 7. So you have to leave this one. You will get 8, 2, 2, 3. Don't forget. Again it's plus, not minus. What is the next main diagonal element? This is 3. What is our cofactor? 8, 7, here minus 6 here. Is easier. Okay, all having plus signs, no minus signs. And you add these two, add all the 3. So 5 plus 20 plus 20, that will give you 45. So S2 is over now. What is S3? As usual, you have to find out det A. So det A is given as 0. Okay, det A is 0 here. So your S3 is 0. So remaining one, lambda cube minus 18 lambda squared plus 45 lambda equals 0. So this is the characteristic equation of this matrix, 3 by 3 matrix. Simpler one. Okay, any doubt? So we will stop today. Okay.